The certification process is based on general science and engineering principles that you probably covered in any science class with a lab that you ever took. The same scientific method applies. Define what the experiment is about, test it, gather the results, then write up a conclusion. From that standpoint, it's pretty simple. It's the details that make things a bit more complex, especially when we're working with airplanes that the public fly in. The first step, define what the experiment is about, can be a lengthy task, and we call it type design. The type design for an airplane is defined by Regulation 14 CFR 21.31, which says it consists of the drawings, specifications, processes, materials, and limitations that define an aircraft. Once type design is defined, you can figure out what needs to be tested, which is what an applicant does to show compliance to the applicable airworthiness regulations. But there is a bit more to knowing what the type design consists of. We also have to know that the parts, assemblies, installations, test articles, whatever we're working with, are built properly and actually match the defined type design. From a scientific perspective, if I test something that I don't fully understand, I can't draw a credible conclusion about the results. There are unknowns like, did the radius of the window affect how it cracked? Or did the wire gauge change electrical interference? So it's extremely important to know exactly what is being tested. That's why an applicant is required to inspect every single part, assembly, installation, and test article 100% of the time.